Hey, welcome back. This is now chapter 11, square root property, completing the square, the distance formula, and the midpoint formula. Okay, so we'll begin with the square root property. And it gives us a shortcut way of solving problems like the following. So if you had x squared equals 9, from what we learned, we would have to set it equal to 0, then factor it, then set each part equal to 0, each factor, and then solve. And we get 3 and -3 as our answers. Okay. Now we'll have this handy property which says if you have x squared equals 9, you can automatically just jump to x equaling plus or minus square root 9. In other words, x equals plus or minus 3, which is the same answer we got using the other method. It's just this is much quicker, right? Okay, so the square root property says basically if you have something of the form u squared equals d, then you can remove the squared part and replace it on the other side with a plus or minus square root of whatever. Okay, so we'll apply this in this next section. What people forget the most is that plus or minus. And I think maybe that comes from working with the Pythagorean theorem, because you're always looking for just a positive distance. And we'll talk about that later, but yeah, please don't forget the plus or minus part. Okay, so let's take a look. 3x squared is 75. So first things I need to do is isolate this x squared part. Okay, so I'm going to divide both sides by 3. And then you could apply the square root property. Okay, let's look at another one. It's the same sort of game. I need to isolate the x squared portion. Okay, so I'll move the 2 over, divide both sides by 3, and then apply the square root property. Okay, and in this case I need to rationalize the denominator, so I'm just going to you can rewrite it as using the quotient property for roots, root 2 over root 3, and then multiply top and bottom by root 3, and we would have our answer. So x is plus or minus root 6 over root 9, and of course root 9 is just 3. Okay, let's get some more variations. In this section, imaginary numbers go. They're part of our answer. We're not just going to write no real answers. We'll use imaginary numbers. But anyways, this same game still. I'm going to isolate the x squared portion. Divide both sides by 25. Square root property, plus minus square root of -16/25. Okay, so this will be the same as plus or minus square root of 6/25 I, 16/25 I. The square root of 16/25 is 4/5, and then we have our imaginary unit I. Okay, let's look at another. This one looks a little different, but you're isolating the thing that's squared. So you're going to try to isolate that x plus 2 squared and then apply the square root property. So it need not just be a single item here. This u could stand for pretty much anything you want to put in there. Okay. So in this case we have x plus 2 in there. I'm just going to isolate that, and then so I'll have 12. And then apply the square root property. So x plus 2 is plus or minus square root 12. Move the 2 over, 12 is the same as 4 times 3, so you can bring a 2 out. So negative 2 plus or minus 2 root 3. Okay. Another one with some more fractions involved. X plus 3/4 squared equals 11/16. So this one's kind of already set up. Just apply the square root property. Okay. Move the 3/4 over, so get negative 3/4 plus or minus square root 11 all over square root 16. Square root 16 is just 4, so let's write it like that. Okay. You can combine the 2 over a common denominator if you'd rather have that answer, but either answer is fine. So, oops, I want to combine the numerators over the common denominator. So negative 3 plus or minus root 11 all over 4. You could also write it that way. Okay. Let's look at one more, and then we'll work with completing the square. So here I have x squared minus 6x plus 9 is 49. Okay. Usually you want to set these equal to 0, but because of the way this one's set up, you can use this method. Okay. So I can rewrite it as 6x minus 3 squared, and then 49 on the other side. Square root property says x minus 3 is then plus or minus square root 49. Square root of 49 is 7. Then add the 3 over. So you get two answers, 3 plus the 7, which is 10, or x equals the 3 minus the 7, which is negative 4. Okay. But you can really only do that because of the way it was set up, and odds are you're not going to see it in the context of just randomly generated polynomials. But in this case, yeah, you can get away with it. Anyways, let's look at completing the square. And in this section, we'll teach you how to complete the square and then how to use it to solve quadratic equations. Okay, but it's really used in a lot of different ways, even in Calculus 1, Calculus 2, students are still using this. But anyways, what is it about? So you'll be given some sort of quadratic, x squared plus bx plus c. We can add in this term, and the result is a perfect square trinomial. So given this thing, we can, there should be a comma here, we can add in b all over 2 squared and form a perfect square trinomial. There's some minor details that we have to kind of iron out. First, this quadratic needs to have a leading coefficient of 1. Okay, so you see it says x squared plus bx plus c. You need to make sure it's not like ax squared. Okay, that won't work. You need to have a 1 in front. Okay, so that's like one issue we'll deal with. Anyways, let's look at example 5 in the book. Part A, they're just asking you to find this number that completes the square and then to rewrite it. Okay, so the number we need is b all over 2 squared. So b in this case is 8, and then we're going to put it over 2 and square it. So this will be 4 squared, which is 16. Then we're going to rewrite the polynomial x squared plus 8x plus 16 and then factor it into a perfect square trinomial. Okay. So it would be x plus 4 times x plus 4, so x plus 4 squared. Okay. Let's look at another one. You have x squared minus 7x. So this time our b is negative 7 over 2, square that. So that'd be 49/4. So I'll have x squared minus 7x plus 49 fourths, and I want to factor that into perfect square trinomial. So I get x minus 7 halves squared. Okay. So this term right here has to be such that when you multiply it, 7 halves times 7 halves, you get 49 fourths. I mean, we could FOIL it out again, see what happens, just to convince you that this is true. So first is x squared. The outer is minus 7x. The inner minus 7 halves x, and then the last plus 49 fourths. And then you can combine these two. Negative 7 halves plus negative 7 halves is negative 14 halves x, and then plus 49 fourths. And of course 14 halves is just your 7x. And of course this thing here is this thing here. Okay. So hopefully that kind of convinces you that this works. Let's look at one more example that has sort of a fraction involved. Okay. So the thing that we're adding in that we have to form is b all over 2 squared. So our b this time is 3/5, and then we're dividing it by 2. Okay. So I wouldn't write this out. I would just write it as times 1/2. Why? Because this is the same as 3/5 divided by 2 squared, and then this would be 3/5 times the reciprocal of 2, which is 1/2. So that's what I'm saying. When you form this thing and you're dealing with a fraction, just multiply it by 1/2, and you'll end up with 3/10 squared, which is 9/100, believe it or not. Okay, so we can form a perfect square trinomial now, and then factor it, the x plus 3/10. So basically, to figure out the 3/10, I just took the square root of the b all over 2, okay? the 9/100. So if you take the square root of this, you end up with 3/10. Okay. Okay, so let's now apply this method to solving quadratics. And the one thing again that I kind of alluded to back there in the beginning, you need to have a leading coefficient of 1. So need a leading coefficient of 1. On your quadratic. So if you don't have that, you'll eventually have to divide by the leading coefficient. I will show you an example of that here in this section. Secondly, once you've accomplished that, you need to add that b over 2 squared to both sides of the equation. Okay, so let's take a look. There's number 35. X squared plus 4x equals 32. Okay, so for these, you're not setting them equal to 0. This is kind of the form you want. Okay, so I don't know, maybe even the first step I would say get it into that form with all the variable stuff on one side and the constant on the other. Then I'm going to form that b over 2 squared thing. So in this case it's 4 over 2 squared, which is 2 squared, which is 4. And then I'm going to add that thing to both sides of the equation. Okay. So on the left you'll have x plus 2 times x plus 2 when you factor it, so that's x plus 2 squared. And on the right you got 36. So it turns into one of these problems where we can apply the square root property. So you'll have then x plus 2 equals plus or minus root 36, which of course is just 6. And then you can move the 2 over. So you get x is -2 plus 6 is 4, or -2 minus 6 is -8. Okay. Okay, let's look at another 39. So here I have x squared minus 8x plus 1 is 0. Even if you attempted to like factor this and set each part equal to 0, you wouldn't be able to. So one reason why you would want to use this method would be because of that. There's no way to factor this into like something times something, right? That it just won't pan out for you. So you're going to have to form the b over 2, in this case -8 over 2 squared. This is -4 squared, which is 16. I maybe should have moved the constant to the other side first, just to be consistent. So you're not, in this case, setting it equal to 0. Okay, once you get it in this form, then add the 16 to both sides. Honestly, it won't matter, but I just want to be consistent with what the book does. Okay. Then I'm going to, factor here. So I have x minus 4 times x minus 4. On the other side, I got 15. Okay. Square root property says x minus 4 is plus or minus root 15. And then finally, x must be 4 plus or minus the root 15. Okay. Let's look at one with more fractions. This one is the video quiz, video quiz, video quiz, video quiz, video quiz. Okay. X squared plus 4/7 x plus 3 over 49 equals 0. Let's move the 3 over 49 over first. Start making that a habit. Then determine the b over 2. And remember, when you're dealing with fractions, to divide by 2, you just multiply by 1/2. Okay. And I need to add that to both sides of the equation. Okay, factor. And then apply your square root property. Square root of 1/49 is 1/7. So we're going to get x equals -2 plus 1/7, which is -1/7, or -2/7 minus 1/7, which would be -3/7. Okay. So that's the video quiz. Let's look at one of these ones where I said you need a leading coefficient of 1. Right. So let's look at one of those. So 49. 2x squared plus 3x minus 5 is 0. So first I'm going to move the 5 over. Then I need the leading coefficient of 1. So I'm going to divide everything by 2. It's essentially multiplying both sides by 1/2, but it's the same as dividing everything by 2. Okay. So I have x squared plus 3 halves x equals 5 halves. Then form your b over 2 squared, so that's the same as multiplying by 1/2. Dividing by 2 is the same as multiplying by 1/2. Okay, so we'll end up with 9/4, or 3/4 squared, sorry, it would be 9/16. One thing at a time. Okay, then I'm going to add that to both sides of the equation. That'll complete the square. I'm going to get a common denominator here as well. So to get 16, I got to multiply top and bottom here by 8. So I'll have looks like 40/16 plus 9/16. Factor on the left, so you get x plus 3/4 squared. On the right, you got 49/16. Then square root property, x plus 3/4 equals plus or minus square root of 49/16 is the same as 7/4. Then move the 3/4 over and get your answers. So -3 plus 7 is 4/4, which is 1. Or -3 minus 7 is -10/4, so -5/2. 1 -5/2. Okay. So I got one more, and then we'll look at an interest problem and applications. So 57, again, imaginary numbers are fair game here. Okay, so first I'm going to move that 7. Then I'm going to divide everything by 2. That'll leave me with x squared minus 5/2 x is -7/2. Get my b over 2, so that would be -5/2 times 1/2 squared. So it's going to be -5/4 squared, which of course is 25/16. I'm going to need a common denominator eventually, so we'll multiply top amount of that guy by 8. Anyways, I got x squared minus 5/2 x plus 25/16 equals -56/16 plus 25/16. Then factor, so x minus 5/4 squared is looks like -31/16. Then square root property, so x minus 5/4 is plus or minus square root of 31/16 I. It's because of that negative under the radical. Move the 5/4 over, so you have 5/4 plus or minus square root of 31 all over the square root of 16. Square root of 16 is just 4 though. And then I. Okay. So those are fair game. If you want to, you can also rewrite this, but I mean that's in the good form. That's the complex standard form, a plus bi. Okay, okay, great. Let's look at some applications. Okay, so we can use these in interest problems. So we have this formula compound for compound interest. I won't go through how it's developed, but it is very interesting. If you go into finance or business, you're going to need to know about this thing. But basically, you have money in a bank account, and it's collecting interest over some small time period. So imagine you have monthly interest. So at the end of every month, they would add some interest into your account. And compound interest just says that that happens every month. So at the end of the month, they'd add more in, and then they would compute the interest based off that new amount. Okay. Anyways, the P value is the amount invested or even the amount borrowed if you're worrying about loans. So this is amount invested. The R value is the rate at which it's being at which the interest is being collected, and it's used as a decimal in the equation. So it'll probably be given to you as a percent, but when you use it in the equation, you got to turn it into a decimal. And then T is time, and for us that'll be in years. Okay. Okay. So story problem. This is just checkpoint 9 from the book. And they say you have a deposit, you make a deposit of $3,000, and after 2 years your future amount is, so maybe I should say A is future amount in this equation. So your future value is $4,320 after 2 years. They want you to use this information to determine the rate. Okay. So basically you just plug all of this stuff into this formula here and solve for R. So A is 4,320, P is 3,000, and then you have 1 plus R, which is unknown, raised to the second power. Okay. Because T is 2, we could solve this. So I'm just going to divide both sides by 3,000. I'm not going to simplify. And then use the square root property. Move the 1 over. And there's 2 answers here, but one of them you could tell is negative, and that's, you don't want that. If you have a negative plus another negative number, it's a negative answer. So we want the positive portion, the -1 plus the square root 432 over 3,000, 4230 over 3,000. If you put that in your calculator, you'll find that the rate as a decimal is 0.2, and then you need to convert that into a percentage by moving the decimal place over 2 places and multiplying by, so you multiply by 100 and then tack on the decimal, the percent sign, sorry. Okay. So multiplying by 100 is the same as just moving the decimal over 2 places. Okay. Okay, so that's cool. Another application is the Pythagorean theorem that I kind of talked about a bit earlier. Pythagorean theorem. And all these answers, you know, they always want like the positive answer. And I think that's why people screw up the plus or minus thing. They always forget to put the plus or minus when you're using the square root property. Right? The square, you always have to have that plus or minus there. Okay. But in these applications, you're kind of always throwing away the negative part. And I think that's a bad habit. So people end up forgetting the plus or minus, and it just becomes a bad habit. And I catch people doing it even once they get to calculus. This will do it. So I hope you're not like that. Here's a triangle. Label the angles A, B, C. And then the sides opposite the angles are labeled A, and then C is over here, and then B is right here. Okay. It's a right triangle, and you can only apply this theorem to right triangles. There's sort of other versions of it, but you need trig to do the other ones. Anyways, side A is considered a leg. Side B is also considered a leg. And then side C is the hypotenuse. Okay, that's the long side. And basically, the Pythagorean theorem says that a squared plus b squared will equal c squared. Okay. Okay, so we'll use that to solve some basic applications. Let's look at 115, problem 115. The ladder problem. So you have a ladder sort of leaning against the house. You know the length of the ladder, and you know how far away the ladder is from the house, but you don't know how high it's going. Okay. So what happens is that it forms a right triangle, and okay, so this side is 10 feet. Then that'll allow you to solve for this kind of unknown height, which we'll call x. Okay. Okay. So the x squared plus the other leg squared must equal the hypotenuse squared. So we'll have x squared equals, I guess, 300 minus 100, and then, 900 minus 100, sorry. Then x will equal plus or minus square root of 900 minus 100, which is 800. And then, as usual, throw out the negative answer. And so x will equal approximately 28.28 feet, depending on the number of decimals they want. Okay. Okay, so there'll be some basic applications there. The last two things in this section are the distance formula and the midpoint formula. So I'll introduce these and then we'll go to the My Math Lab and see what fun they have in store for us. So here we have the distance formula. Okay. So to find the distance in 2 dimensions on the number line, like maybe going from -2 to 7, what you do is just take the absolute value of the difference. So the distance would equal the absolute value of 7 minus -2, which will be 7 plus 2, which is 9. Absolute value of 9 is 9. Okay. So this is 2 dimensions. Oh, sorry, that's actually 1 dimension, right? That's just 1-dimensional. Okay. For 2 dimensions, it's different, right? Because we're in the XY plane. And maybe not entirely clear how to get the distance between, say, x1, y1 here, and this other point we'll say is x2, y2. Okay, so what you're after here is the distance right here. If I took a ruler and measured that, I need to know how far that is. Okay, but you could cheat. You could say, well, that's just the hypotenuse of a right triangle. And then we can kind of get the sides, the leg sides. So I'll say this side we'll call D. And so from the Pythagorean theorem, D squared must equal 1 leg squared. So x2 minus x1 squared plus this other leg squared. So the distance of that leg must be y2 minus y1. Square it. Okay. And then just take the square root on both sides. We don't need the negative sort of answer. So we just have x2 minus x1 squared plus y2 minus y1 squared. Okay. And that's your distance formula, and everybody should know that. Okay. You'll need it memorized, so memorize that thing. Memorize me. Okay. The problems in the software aren't that bad, but sometimes they'll try to make it tricky by putting in fractions, square roots, decimals. Okay, so here, trying to find the distance between these 2 points in the plane, the XY plane. So you go x2 minus x1. It's a little like slope, isn't it? And you could actually make some connections between this distance formula and the slope formula later on. Then plus 6.2 minus 8.2 squared. Okay, so this will be the square root of -4 squared plus, really, -2 squared. So that'll be the square root of 16 plus 4, which of course is square root of 20, which is 2 root 5. Okay, so that's one formula. The other formula, not as important, but we'll give it to you. I won't force you to memorize this one. It is the midpoint formula. Okay, and it's basically, again, you'll have 2 points in the plane like you do up here, and what you're looking for with the midpoint is kind of the point like right there. Okay, so to figure that out, what you have to do is kind of take the average of x1 and x2, and that'll be your x coordinate. So the average, you just add them up and divide by 2. And then for the y coordinate, you're just taking the average of y1 and y2. Okay. So you add them up and divide by the number of points. So 2. Again, the exercises aren't really that hard. It's just they kind of give you some crazy numbers that you have to deal with. So maybe fractions, or again square roots and stuff like that. So here we have a bunch of fractions. So the midpoint, I gotta add these together. So -7/2 minus 5/2 over 2. And then adding these together, I got 11/2 negative plus 3/2 all over 2. So we'll get sorry, negative 12 halves is negative 6 over 2. And then 8, negative 8 over 2. Negative 8 over 2 is negative 4, and then all over 2. So we'll have negative 3, negative 2 for our midpoint. Okay. Okay, so that's the the big and small of it. Let me now go to Webassign to see if they have anything crazy going on that we need to look at. Okay. Okay, so let's just kind of go backwards. Okay, so I like this picture. It's like camouflage pattern. Square flower bed is enlarged by adding 3 meters on each side. If the large square has an area of 121 meters, what's the length of the original square? Okay, so it's originally a square. That we don't know these lengths, so we'll just call each side x. Then we increase it by adding 3 meters on each side. Okay, so basically we're going to extend it by 3 here, 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 and we get this new flower bed. Okay. The sides of that flower bed then are x, and then if this is 3 and this is 3, it'll have to be x plus 6 total. X plus 3 plus 3, right? And likewise for this, it'll be x plus 6. And then it's saying that the area is 121. So to find area, you just take the sides and multiply them by each other. It's 121. It's kind of set up to be then a square root property problem. Right? So square root property, x plus 6 is plus or minus. Square root of 121 is 11. And then subtract 6. So clearly the minus 11 part won't work. So we need negative 6 plus 11. So 5. And that would be in meters. Okay, so there's the ladder problem I did. This is, I guess I didn't do this one. Okay, so the accompanying bar graph shows the number of billionaires worldwide from 1992 to 2017. The data can be modeled by these functions where f of x and g of x, the number of billionaires worldwide after x years after 1992. Okay, which one is the better model for the 2007 data? So you're going to have to look at the 2007 data. In 2007, and we're saying x years after 1992, so I need to figure out how many years 2007 is after 1992. So what would that be? 15 years. So x is 15. So what I want to do is put 15 in each function and see which one is closer to the actual number of billionaires, which is 933. Okay, so f of 15 will be 2 times 15 squared plus 283, and then g of 15 would be 3 times 15 squared plus 275. I'm going to go to my calculator. Okay. Squared. No, it's just going nuts on me. 15 squared times 2. It's giving me the square root. I don't want the square root. Did I not hit this button? I guess that's their symbol for squaring. Let's try it again. 15 squared times 2 plus 283. And then the other guy, 3 times 15 squared plus 275. Okay, so clearly function g is better because it's 950, which is closer to the 933. Okay, so G is better. According to the function part of A, in what year will there be 3,158 billionaires? So 3,158 equals this 3x squared plus 275. So I'm going to move the 275 over. 3,158 minus 275, 283. Divide by 3, hopefully. It's 961. Take the square root property, plus or minus 961. Of course, we just want the positive version. Oh, they gave me a nice little answer, 31. So 1992 plus 31. 2023. Oh, that's it. Okay. This is one where you're doing the compound interest. I showed you how to do those. Okay, just finding the rate. Solve. This one's weird because it has some funny variables in there. Okay, so I have to solve this by completing the square. So the first step is to figure out your b over 2, and coincidentally our b is equal to b. Okay, so I'm going to square that. I get b squared over 4. So I have x squared plus bx plus b squared over 4 equals 12b squared plus b squared over 4. Factor it, so it'd be x plus b over 2 squared equals, I'm going to combine these together with a common denominator. Okay, so top and bottom by 4. So you end up with what, this thing, I'm just trying to save myself some space here, but it'd be 48 fourths b squared plus this other b squared over 4, which is the same as 1/4 b squared. Okay, let me combine those and then we'll do the square root property. So you got 49 fourths b squared. Square root property, we have x plus b over 2 equals plus or minus 7 halves b. Okay, and then we can move the b over 2. So x equals negative b over 2 plus or minus, let's just write it as 7b over 2. And then x is negative b plus 7b is 6b over 2. So we have 3b, or x is equal to negative b over 2 minus 7b over 2 is negative 8b over 2, which is negative 4b. Okay. Okay, so 3b comma negative 4b. Okay. So we'll try this one. So this one's kind of different because it has a bunch of fractions in it. So, I'm just gonna, I gotta multiply by 5 to get a leading coefficient. Let me move the 1/10 over. That's kind of our standard procedure. Okay, multiply everything by 5 then, because you need that leading coefficient of 1. So you get x squared. When I do that, then this times this, so we get 1/3 x, or x over 3. On the other side you have 5/10, which is 1/2. Okay. Now we can complete the square. So our term would be negative 1/3 divided by 2 is the same as multiplying by 1/2 squared. Okay, so negative 1/6 squared, which is 136. Add that to both sides. I need a common denominator as well. So whoops, this will be 18. So we get 18 all over 36 plus 1 over 36. So we'll have x minus 1 over 6 squared equals 19 over 36. Square root property, plus or minus square root of 19 all over 6, and then add the 1/6 over, plus or minus square root of 19 over 6. So let's go ahead and type it in. Yeah, I don't think you're supposed to use the plus or minus thing here. You kind of have to put them in with commas. 6 plus, you have to go to the backslash, square 19 all over 6, comma, and then if you want to, you could always comma, then space apparently. Fraction. And for some reason, it's putting the comma in the numerator. You know, put a space there. Let me write this one differently. 1 minus slash squirt of 19 all over 6. I don't know if that'll save any effort. Space. Oh, this one. Solve the following for the specific variable. So a equals p times 1 plus w squared. So divide both sides by p. Square root property. They're going to apply 1 to the rationalize here. I can only assume. So, you know, it's square root of a all over the square root of p. Multiply top and bottom by square root of p. Okay, and then move the 1 over. And we're going to have to use the plus or minus in our answer apparently, unless it says something. Oh, the principal square root. When it says principal square root, you're only using the positive portion, so we only have to worry about plus. Okay. And then all over a square root of p squared is just p. Make sure you use capital A, capital P. -1 plus fraction slash square root a p all over big P. Let's see if that works. Yay. Same sort of deal there. Just make sure you're using the right. Jeez. 3 times the square of the difference between a number and 2 is -48. 3 times the square of the difference between a number and 2 is -48. There is no number. Oh, you can use i's. Okay. X minus 2 squared is -16. So x minus 2 is plus or minus 4i. And then x is 2 plus or minus 4i. The numbers are 2 plus 4i, comma 2 minus 4i. Find the midpoint. Okay, so you can find midpoints and stuff. It's just plug and chug. Okay, we'll leave it at that. Thank you for watching, and I will see you next time.